In this particular presentation, I will be talking about 8086 instruction set with the first type of classification of the 8086 microprocessor instruction set. Subject is microprocessor KCS403. My name is Gaurav Parashar and I'm from the computer science department. So in the contents over here, we'll be mentioning about the instruction set of 8086 and the particular classification of 8086 instruction set that we'll be discussing in this presentation are data transfer instructions, arithmetic instructions, and logical instructions. Now let us try to understand what actually is the particular first type of first category, and that is the data transfer instructions. So the instructions that are used to transfer data or address into registers or memory locations and I/O ports. So this type of instructions are called as data transfer instructions. Generally, they involve two operands. One is the source operand and the other is the destination operand. And important is they are of same size. Now the source. So what's a source? It is a register of the memory location or an immediate data. And what is the destination? So the destination is either the register or the memory location where the data will be copied into. The size should be either 1 byte or 1 word. So let us talk about the other type of different data transfer instructions which are there. So these are like MOV, XCHG, push, pop, in, out, and many other. So we'll be discussing about all these particular instructions. Now let us try to understand how a move works. So a move instruction actually works like this. That move, we have a source and destination. So this is the destination and this is the source. So the data from REG1 is copied into REG2 if it is like REG1, REG2. If it is like register to memory, so it will be written as MOVM, REG1. If it is from memory to register, it will be written as REG2, MEM. So this is how we have to use these particular instruction with move. Now there is one more variant of this particular MOV instruction, that is data, that is immediate data. So you can transfer the immediate data into the register or the memory. As you could see over here, that the data is on the right hand side, that's on the source side, and the destination is the register. So data will be copied and pasted inside the register. And as you could see in the second example, data will be taken and copied into the memory. Now let's talk about the exchange. Exchange means the swapping of the values of the operands. So over here we have two operands, register 2 and register 1. So data of register 1 will be copied to register 2 and register 2 will be copied to register 1. And same happens in the second example. The register 1 will, the content of the register 1 will be copied to the memory, and from the memory the data will be copied to register 1. Now let's talk about the push instruction. So push is basically we do something on stack. So it's like push REG16. So it is like 16-bit data will be copied onto the stack. And push mem, that is data will be copied from memory and will be pushed on the stack. Now pop is like we are popping the data from the stack and putting that thing into register or memory, as you could see over here. Now coming to the in and out are two basic categories of instruction, of data transfer instruction, where you are communicating with the ports, that is the input and output ports. So as you could see over here, that the DX register is taking and storing the data in A. DX content is copied into AL, that is 8-bit, and DX is copying into AX. So all these are the different examples of the instruction. And as you could see over here also, what you are doing over here, it is the address. Source is the address. Okay, So if this address is transferred to A, address of 8-bit is transferred to AL, and address is transferred to AX. Now coming to out is just opposite of it. So when you are doing something from a system to port, so when you want to do something from system to port, system means that microprocessor to the port which is the output port, will use this out instruction. So we'll be copying the data from these AL or AX, and we'll be pasting into this DX. Okay, and same here. So AL, and AX will be copied into this onto this particular address. Now, second type of instructions category that we'll be talking about is the arithmetic instructions. So arithmetic instructions are add, add with carry, subtract with borrow, increment, decrement, multiply, divide, and compare. Now let us try to understand that how an add works. So ADC, ADD, on ADD, immediate. So this is ADC. ADC means add with carry. So register 1 and register 2 will be added with carry over here, right? So this is memory and register will be copied, and register 1 and memory will be taken, and data will be saved in the memory. Over here data will be saved in register 2, and over here also data register 2 will contain the results. And same in this thing also, that the data which is immediate data, so the register and data will be added and saved into the register. Memory contents and data will be added and saved in the memory again. And over here, as you could see, that 8-bit data and AL. So AL is 8-bit register. So AL contents and data of 8-bit will be added and saved in the AL. AX is 16-bit. Therefore, so 16-bit data and data, immediate data 16 will be added and saved in AX. Now we have already seen this, but the only difference over here is the carry flag. So carry flag is like adding the value of the carry. So ADC is adding the value. Now, so over here, the only difference from here to here is that we are adding extra carry. This is the extra carry that we are adding. Now let's come to the subtract. So subtract is subtraction. So either you can subtract two values, like register 2 and register 1, right? And subtracting it and saving it in the register 2. Okay, either save it in register or the memory, as you could see over here. Same here, the data. So you will take the register, subtract the data from it, and saving the content in the register itself or the memory. Okay, and this is like subtracting it from the 8-bit data and subtracting the 16-bit data. Subtract with borrow is like decrementing the second value from the first value. Okay, so this is we are taking the second value from the first value, and then decrementing the carry flag also. Okay, same here in the SBB register mem data or SBB A data. Now let's talk about the increment. So increment is like +1. So over here, as you could see, INC REG8. So RNC REG8 means that register is added with 1. Okay, 16-bit added with 1, or memory's contents are added to 1 with 1. And DEC is decrement. So register decremented by 1, register 16 decremented by 1, memory is decremented by 1. Now coming to the multiply. So multiply is multiplication. So what you would do in it, that you will use one register or memory as it tells. So for a byte instruction, what you would do, you will take an AL register and multiply it with the register. Okay, so if I use something like this, that then what will happen in this case is that AL will be multiplied with the register 8. Over here, as you could see, if I'm doing something with AX to multiply AX, so AX and register 16-bit would be multiplied and save the content in DXAX. So why DXAX? Because there will be a spillover. So any extra value which is spilled would be saved in the DX for word. And same happens for the memory. IMAL is for immediate. So as you could see, this is IMAL. Coming to this part, this is division. So division is dividing the content. So as you could see over here, that if I take div and the register, and register is 16-bit, so if we divide it, what will happen is that we will get the quotient in the AL and the remainder in AH. For 32-bit, we'll get in AX and DX. And same happens in memory. Now comparison. So in comparison, what we do is that we compare the contents of two registers. As you could see over here, that if the comparison goes like this, register 2 is greater than register 1. So if it is register 2 is greater than register 1, then the carry flag, zero flag, and sign flag all are reset. If it happens that register 2 value is less than the register 1, so carry flag is set, sign flag is set, whereas zero flag is reset. Whereas if both the values are equal, that is, that register 2 contents is equal to the register 1 content, then carry flag is reset, sign flag is reset, zero flag is set. Okay, for equality, zero flag is set. For register 2 is less than, carry flag and sign flag are set. Whereas in the when register 2 and register 1, register 2 is greater than register 1, so all are reset. Okay. Now coming to the second example of it. So second example is we are comparing the register with memory, and over here is memory with register. So this same as above, only the parameters have changed. Same here, we are taking the data, that is immediate. Okay. Now we have to understand the logical instructions. So logical instructions are AND, OR, XOR, test, SHR, SHL, RCR, and RCL. So what are these? AND is ANDing. So this like bitwise AND. So over here, as you could see, if we do an AND with register 2 and register 1, so register 2 and register 1 bits are ANDed, and the result is saved back in the register 2. That is the destination register. Okay, so it can be a register memory, or memory register, or data. You can have directly, you can supply data and could be done on it. Same happens in OR. So in OR, we do like register memory, memory register. So it is OR, a logical OR. Coming to XOR. So XOR again, same. This is the bitwise XOR. Coming to test. So test is actually doesn't do anything but modifies the flags. Okay. So it adds and modifies it. It is important to understand that the result is not important, so it is discarded, and only the flags are important. Therefore, if we are adding, to all the flags will be added using the test, and it will be saved. Shift right. So shift right is that we are moving towards right, and anything which goes out of the register is actually discarded. So as you could see over here, when we are moving towards right, so the bits are being propagated to the next consecutive place, and the least significant bit actually goes out and sent to the CF. CF is the carry flag. Shift right means that you are shifting towards right, and what happens in this case is that it moves like this, and anything which comes out from the MSB is transferred to CF. Now RCR is rotation. Okay, rotate right and rotate left. So RCL is rotate left and RCR is rotate right. So the main thing you have to understand in rotation and shifting, that rotation means that anything which comes out from the least significant bit when you are operating on RCL RCR means write. So the least significant bit is transferred to the most significant bit place. Okay. So anything which spills out from here will be copied to the MSB. Okay. And it is just the opposite in left moving. So when we move left, so when you're moving left, in this case, as you could see, when we are moving left, so anything which comes out from the MSB is transferred to the LSB. This is the difference. And that's all in this presentation. Thank you.